Okay, welcome again to the course on fundamentals of mechanics. Today we will be doing further simplifications of force and couple system. In the last class, we were discussing those structural elements or machine components which were subjected to a number of forces. We resolved or replaced all those forces by a single force and all the moments by the forces by a single force, all the moments of the force by a single force. So in the previous class, we understood how we can replace all the forces acting on a structural element or a machine component by a single force. And the moments of those forces can be replaced by a single moment. So now we have discussed that on a machine element, whatever be the forces, whatever be the number of forces, we can replace all those forces by a single force. And we can replace all those moments of the forces by a single moment. Now, in today's lecture, we'll be discussing further simplifications of force and couple system. What do we mean by further simplification? It means that in the previous class, as we had a number of forces were acting on a machine element, and we replaced them by a single force and a single moment. But now we can replace the single force and single moment by a single force. Okay, that is, I mean to say, for example, let's discuss this problem. For example, as this problem is here, it says in each case, determine x and y components of the resultant force. And specify the distances where this force acts from point O. So what we will be doing in these questions? In these questions, we will be replacing these forces by a single force, and the moment of this force will be replaced by a single moment. And then the force will be placed along this beam in such a way that it takes into consideration the moment which is produced by these two forces. I mean to say, let's first of all calculate, since we have to do all the analysis at point O, let's calculate all the forces about point X. As we calculate all the forces about point X, there is no force acting along x-axis. We say all the force acting along x-axis is 0. Now, let's calculate all the force along y-axis. As we went on to calculate the force along y-axis, we have to be very careful before solving any question that we should select our x-axis and y-axis. Let's say this is our x-axis. Let's call this as our x-axis. And let's call this to be our y-axis. Though we are free enough in selecting the x and y-axis. Let's call this to be our y-axis. So this is our y-axis, and we say this is our x-axis. So we don't have any force acting along x-axis. Summation of all force acting along x-axis is 0. Now all force along y-axis, since we have a force 200 Newton acting along minus y, so it is minus 200 Newton. So this is a force of minus 200 Newton. And we have a force of 260 Newton acting along minus y. That's why we'll say it is minus 260 Newton. And both these forces will be equal minus, the resultant will be minus 460 Newton force. So we have minus 460 Newton force acting, and this force will be acting in negative direction. Now, let's take the summation of all the moments. So it means these two forces can be replaced by a single force at point O, such that the force will be acting in y direction, negative y direction, and its magnitude will be 460 Newton. That means this force and this force can be replaced by a single force having magnitude of 460 Newton. Now, what about the moments? Summing up all the moments about an axis passing through point O, that will be equal. We will have moment because of this 200 Newton force, that will be 200 Newton into 22 meter. That is 200 Newton multiplied by 2 meter. Okay. And this 200 Newton force is trying to rotate this beam in the clockwise direction. Therefore, we'll take this as negative. And the moment because of this 260 will be 260 Newton multiplied by 4 meter. Since this 260 Newton is also trying to rotate the beam in clockwise direction, therefore this will also be negative. Therefore this is equal minus 400 Newton meter. This is and minus 1040 Newton meter. That is totally equal. This total is equal. This is equal minus 1440 Newton meter. 1440 Newton meter is the total moment. Now it means we can replace these two forces. Don't show these two forces acting on the beam. We can replace these two forces by a single force at point O, and the force will be acting in the downward direction such that the force will have a magnitude of, force has a magnitude of 460 Newton. So we'll write this as a force of 460 Newton. So we have replaced these two forces by a single force, and at point O we also have moment, negate clockwise moment, because it's minus. So we'll replace it by a moment of 1440 Newton meter. So we'll write here this is 1440 Newton meter. Since we have already shown it to be clockwise, therefore it's already negative. Okay, now this is what we had done in the previous class. We had replaced a series of forces by a single force and the moments of these forces by a single moment. Now we can further simplify it. Okay, we can replace this force and a moment by a single force. For that purpose, what we will do, this is the topic for today. Okay, we'll be replacing the force and the moment by a single force. That is, see, if we can move this force, if we can move this force of 460 Newton, if we move along this beam to some distance, let's suppose this force of 460 Newton is not acting at this point in negative direction, lines y direction. Let's suppose that this force is acting on the beam at a distance. Let's suppose it's acting at a distance. It's acting at a distance from point O. It's acting at a distance from point O, and the distance is, say, for example, small d. Okay, we say the force of 460 Newton is not acting at point O. Let's suppose it's acting at a distance. It's acting at a distance d from point O, and its magnitude is 460 Newton in downward direction. Therefore, but at point O we also have a moment. If this force has been moved to a distance d, this force d has to satisfy two conditions. First of all, its magnitude and direction should not change. Number two, the moment at point O, that is 1440 Newton meter, should be equal to the moment created by 460 Newton at a distance d about point O. That is, the moment 1440 Newton meter, magnitude will be taking 1440 Newton meter moment, it should be equal to the moment produced by 460 Newton when it is displaced to a distance d. That is, the moment because of this 460 Newton will be force, that is 460 Newton, multiplied by its force arm, that is d. Okay, so this Newton and Newton will cancel. D comes out equal to 1440 divided by 460 meter, which is equal to 440 divided by 1440 divided by 460 is equal to 3.130 meter. This is equal 3.130 meter. This is very important. So it means that initially we had two forces acting on this beam. We replaced these two forces by a single force. These two forces had moment about point O. We calculated the moment was 1440 Newton meter. So we replaced the forces by a single force and the moment of these forces by a single moment. Now what we are doing, we are replacing this force and the moment at point O by a single force at a distance d from point O. Okay, that means when we are translating this force of 460 Newton from point O to a distance d, we are saying that the magnitude and the direction of 460 Newton does not change, number one. Number two, this force of 460 Newton at a distance d produces the same moment at point O as the moment of 1440 Newton meter. So if you 1440 Newton 1440 Newton meter moment should be equal to the moment created by a force of 460 Newton at a distance d. Therefore, d comes out equal to 3.130 meter. It means that we can replace this force of 460 Newton at point O. We can replace this moment of 1440 Newton at point O by a single force of 1400 by a single force of 460 Newton acting at a distance 3.13 meter acting at a distance 3.13 meter from point O. Okay, at a distance 3.13 meter from point O. So this is quite interesting. So from point O, if you go to a distance of 3.1, if from point O, if we go to a distance of 3.13 meter and apply a force of 460 Newton meter, apply a force of 460 Newton, then the effect of the force of 460 Newton at a distance 3.13 meter from point O will have the same effect as the effect of the forces 200 Newton and 260 Newton acting on the beam from a distance of 2 meter and 4 meter respectively from point O. So this is, we are replacing the forces acting on any structural element or machine component by a single force and single moment at point O. Then that single force and single moment can be replaced by a single force. The force is to be translated. This is called the further simplification of force system resultant. Okay. So now we have a question 2, and the question is, we have a plate, okay, and this plate is a square plate. Its length is 2 meter, its width is 2 meter, and this plate at the given coordinates is subjected to different forces. It is subjected to forces of 200 Newton, force of 100 Newton, and 200 Newton again at different coordinates which are given to us. We have to replace all these forces by a single force, okay, and uh, the forces will have some moment, okay, uh, about x, about any of the x's. We will be replacing all these forces by a single force, and the moment of all these forces will be replaced by a single moment. Then that force and moment will be replaced by a single force. Okay, how we do it? The same way as we did the previous question. Let's solve it. So we will having sum up all the forces. There are no forces acting along y direction, so sum of all the forces along y direction has to be equal to 0. There are no forces acting along x-axis, that is summation of all the forces, summing up all the forces along x-axis has to be equal to 0. Now as far as the z direction is concerned, let's sum up all the forces along z direction. As far as summing up all the force along z direction is concerned, we are having a force of 200 Newton along minus z, so we'll write minus 200 Newton. So we'll write this as minus 200 Newton force. We're having a force of again minus 200 Newton. So this is minus 200 Newton force. So this is minus 200 Newton force. And we're having a force of 100 Newton. So this is minus 100 Newton because it's acting along minus z. So this is minus. So the total forces acting are minus 500 Newton. So all these three forces we can replace by a single force. So we can replace, there is no need to write this force here, no need to write this force here, no need to write this force here. All these three forces can be replaced by a single force whose magnitude is 500 Newton, and this force should be acting along negative z direction. Now the moment of the forces is to be taken into consideration. How much is the moment of these forces? Let's take the moments about an axis passing through point. Let's call this origin as point O. Okay, let's call this origin as point O and start taking all the moments about an axis passing through point O. So this is the resultant force. Now first we take the moment because of this summing up all the moments. This is step number 2. Summing up all the moments about an axis passing through point O. So first we'll be taking the moment because of this 200 Newton force. This 200 Newton force, the moment because of this 200 Newton force is equal force into force arm, that is 200 Newton multiplied by the force arm, the perpendicular distance between this point O and the line of action of the force is 1 meter. So this is 1. So force unit is Newton, distance unit is meter. So it is 200 Newton meter. The moment because of this 200 Newton force about an x is passing through point O, okay, that will be, and see this is trying, this 200 Newton force is trying to rotate the system in the clockwise direction. That's why we'll be taking it as minus. This is minus. Okay. Again, or we see once you have to be very careful about the direction here. Uh, we were calculating the moments about from an axis from point O. We are calculating the moments of force. We are calculating the moments. You are calculating the moments of 200 Newton force from point O. So our radius vector will be from point O to the line of action of the force. Okay. So the force is acting downwards. The force is acting downwards. The force is acting downwards. It's like this. This is our radius vector. This is radius vector. This unit is 100 meter. Now we know the moment is equal to r cross f, and the direction is given by the smallest angle between r and f. Okay, so the smallest angle between r and f, we have to get them on the same terminus. So we will be producing this r slightly. This r will be producing slightly in the same direction. Now our r and f, this is our f, this is our r and f. Now we have to move from r to f through the smallest direction. As we are moving from r to f through the smallest direction, the direction is like this. If we curl our fingers, in this direction, in the direction of this arrow, as we are moving from r to f through the smallest angle, the thumb comes along the y direction. Okay, the thumb is along the y direction. The thumb comes along the y direction. Okay, the thumb is here. Since the thumb is along the positive y direction, therefore we will say the moment because of this force has to be positive. We'll say the moment because of this force of 200 Newton has to be positive. The moment because of 200 Newton force is 200 Newton multiplied by a distance of 1 meter multiplied by 1 meter. 200 Newton meter will be the moment, and this 200 Newton meter moment will be positive because the r to f, as we move from r to f, the moment is in the direction of what you call as it's in the positive y direction. That's why this is positive. Okay, now again taking the moment because of this 200 Newton force, next 200 Newton force, again the moment will be 200 Newton multiplied by 2 meter, that is 200 Newton multiplied by 2 meter. So this is 200 Newton multiplied by 2 meter. Now whether this moment is positive or negative, that is what we have to see. Now this moment is, we can at least see when we are writing this 200 Newton meter. Let's write this in the vectorial form for some reason. Let me rub it here. Okay, so this, we can also write it this 200 Newton because we are taking moments. Once you are taking the moments of this 200 Newton force, it will be about an axis called y-axis. So I will write this as this moment is along j cap. I will write here j cap. Okay, and it's positive. Now the moment of this 200 Newton force is 200 Newton multiplied by 2 meter. Okay, and whether this moment is positive or negative, again draw the radius vector. R. This is your r. Since f and r, their edges or their heads are at the same point, in order to find the angle, I have been saying that you have to get the tail of one and head of another. So your force is in the downward direction. So as far as r is concerned, this is our radius vector r. This is our f. Okay, so the moment of the force is 200 Newton multiplied by force arm. Move from R to F through the smallest angle. The and curl your fingers. The thumb will come. The direction of the thumb will be in this direction, minus x-axis direction. Therefore, you will write this as this moment is minus j cap. Sorry, minus I cap. This moment is minus I cap. Okay. Now we'll be taking the moment because of this 100 Newton force. In order to calculate the moment because of this 100 Newton force, the moment is the moment because of this 100 Newton force will be equal to force multiplied by the force arm. The moment because of this 100 Newton force will be now force is 100 Newton multiplied by the force arm, the perpendicular distance. Okay, the perpendicular distance, we will be taking this r cross f, or the force into force arm. The perpendicular distance between this point O and between the point O. Okay, the perpendicular distance is 2 meter, or if you calculate perpendicular distance from here, that is 2 meter also. Okay, so we'll be writing 100 Newton multiplied by 2, that is Newton meter. Now, what is the direction of this moment? Again, in order to find the direction of the moment, what we'll be doing, we'll be drawing the radius vector from point O. This is radius vector. Force is downwards. The force is acting downwards. Now, it means this R, let's reduce this R slightly forward. This is our R. Now, this is our R. This is R. This is F. Okay. As we move from R to F through the smallest angle, as we move from R to F through the smallest angle, what could be the direction of our moment? Okay, the direction of our moment will be, as the direction of our thumb is in this direction. Our thumb is in this direction. We're here. Oh, sorry, here. Okay, this is the direction of our R. Okay, so this 100 in 200 Newton meter force is to be, we have to see whether this force, this moment of 100 Newton force is positive or or negative. Okay, see again,